the vastness of the cosmos has been a source of both wonder and confusion for centuries. Since the early days of astronomical observation, humans have looked to the stars and wondered about the origins of the universe. Many of us are familiar with the story that begins with the Big Bang, a cataclysmic event that supposedly created everything in our universe around 13.8 billion years ago. This has been the cornerstone of modern cosmology, shaping the way we view the universe and our place within it. However, recent groundbreaking discoveries made by the James Webb Space Telescope, JWST, are forcing scientists to rethink the very foundations of our understanding. What was once thought to be a well-understood narrative about the creation and evolution of the cosmos is now being questioned in light of new evidence. For most of the 20th century, astronomers and physicists believed that galaxies like our Milky Way took billions of years to form. According to this model, the earliest galaxies should have appeared only a few 100 million years after the Big Bang, gradually growing in size and complexity over time. This timeline was built on our understanding of galaxy formation, which suggested that the process was incredibly slow and required vast periods of time. This concept seemed logical and was supported by a wide range of observations, but the launch of the JWST has turned this theory on its head. The James Webb Space Telescope, launched in December 2021, was designed to observe the farthest reaches of the universe, peering into the earliest moments of the cosmos. With its incredible infrared capabilities, Webb is able to look back in time further than any previous telescope, unveiling galaxies that formed just a few 100 million years after the Big Bang. Webb's discoveries have been nothing short of revolutionary, and they have already begun to challenge many of the assumptions that cosmologists have relied on for decades. Perhaps the most shocking revelation from the JWST is the discovery of galaxies that are not only older than expected but also far larger and more evolved than what was previously thought possible for such early periods in the universe. These galaxies, identified by the JWST, appear to be much more mature and developed than they should be, given their age. According to our current understanding of cosmology, galaxies that formed just 500 million years after the Big Bang should be in their infancy, with stars and structures that are far less complex than those we see today. But Webb has revealed galaxies that are up to 10 times larger than the Milky Way, some of which are already fully formed and have undergone significant evolutionary processes. Michio Kaku, a renowned theoretical physicist and one of the most prominent voices in modern science, has weighed in on these discoveries. Kaku, who has long been an advocate for new ideas in physics, has suggested that these findings could mark the beginning of a new era in cosmology. He believes that we may have to rewrite our textbooks on the origins of the universe and the evolution of galaxies. According to Kaku, the discovery of these massive, mature galaxies in such a short period after the Big Bang challenges the very foundations of our understanding. These findings suggest that the universe's history may not be as straightforward as we once thought, and that there may be new physics at work that we have yet to comprehend fully. One of the most intriguing aspects of these new discoveries is the size and maturity of the galaxies that Webb has identified. Galaxies like the ones discovered by the JWST should not have been able to form in the early universe. According to the standard model of galaxy evolution, it takes billions of years for galaxies to grow and mature to the size of the Milky Way. But Webb's observations suggest that galaxies can grow much faster than we previously thought. Some of the galaxies discovered by the telescope are not only larger than the Milky Way, but they are also far more evolved, with complex structures and a wide variety of stars. This has led to speculation that we may be seeing evidence of an entirely different process of galaxy formation, one that is much faster and more efficient than what we have observed in the past. Some scientists, including Kaku, suspect that the findings from Webb could point to a new understanding of how galaxies form and evolve in the early universe. Kaku has suggested that this could be the beginning of a new era in physics, where new models like string theory and the concept of the multiverse may finally find support. In fact, the discovery of these large, mature galaxies could also have implications for our understanding of the Hubble Tension, a long-standing problem in cosmology that has puzzled scientists for decades. The Hubble Tension refers to a discrepancy between measurements of the expansion rate of the universe. Over the years, scientists have used various methods to measure the rate at which the universe is expanding. One of the most well-known methods involves studying the cosmic microwave background, CMB, radiation, an ancient signal left over from the Big Bang. When scientists use this method to measure the expansion rate, they obtain a value of about 67 to 68 kilometers per second per megaparsec. However, when scientists use other methods, such as studying the brightness of certain types of supernovae, they get a much higher value, around 73 to 74 kilometers per second per megaparsec. This discrepancy, known as the Hubble tension, has been one of the most significant unresolved issues in cosmology. Some scientists have speculated that the difference could be due to unknown factors related to dark matter or dark energy, while others have suggested that there may be fundamental flaws in our current models of the universe. The discovery of these massive galaxies, which appear to have formed much more rapidly than expected, could provide some insight into the Hubble tension. If galaxies are forming more quickly than we thought, this could mean that the expansion rate of the universe is not what we currently believe it to be. As these new discoveries challenge the traditional view of galaxy formation and the evolution of the universe, they also force scientists to reconsider some of the basic assumptions that underlie our understanding of cosmology. For example, the idea that the Big Bang marks the beginning of everything is now being questioned. Kaku has long argued that the Big Bang may not have been the ultimate origin of the universe but rather the beginning of our universe, a single, isolated cosmos within a much larger multiverse. This theory, known as the multiverse hypothesis, posits that there may be many other universes, each with its own set of physical laws. In some of these universes, the laws of physics could be radically different from what we observe in our own universe. The idea of a multiverse has long been considered speculative and has not been widely accepted by mainstream science. However, with the new discoveries from the James Webb Space Telescope, the possibility of a multiverse is becoming more plausible. The discovery of large, evolved galaxies in the early universe suggests that the cosmos may be far more complex than we ever imagined. If our universe is just one of many in a vast multiverse, then the laws of physics that govern our universe may not be the same in other universes. This would mean that the Big Bang was not the beginning of everything but rather a singular event in a much larger and more diverse cosmic landscape. Moreover, these new discoveries may point to an even deeper truth: our understanding of the universe is incomplete. The James Webb Space Telescope has already provided a wealth of data that is forcing scientists to reconsider the basic tenets of cosmology. The galaxies discovered by Webb are so massive and mature that they cannot fit into the existing models of galaxy formation. This suggests that we may have missed something fundamental about the nature of the early universe, something that could revolutionize our understanding of cosmology. One of the most exciting aspects of these findings is that they may open the door to new physics. As Kaku has pointed out, the discoveries made by Webb could lead to the development of entirely new models of the universe. These models could incorporate ideas like string theory, which seeks to unify the forces of nature, and the multiverse, which suggests that our universe is just one of many. If these new ideas are proven to be correct, they could fundamentally change our understanding of the cosmos and our place within it. For decades, scientists have been working within the framework of a model that views the universe as a single, isolated entity, created by the Big Bang and governed by the laws of physics as we understand them. But the discoveries made by the James Webb Space Telescope are challenging this view. If the universe is far more complex than we previously thought, if it contains other universes with different laws of physics, then everything we thought we knew about the cosmos could be wrong. These revelations may be the beginning of a new era in science, one in which new physics and new models of the universe are developed to explain the mysteries that the JWST has uncovered. In the coming years, as more data is gathered by the James Webb Space Telescope, we may begin to unravel the true nature of the universe. These discoveries have already provided us with a glimpse of what's to come, and the possibilities are truly exciting. We are on the verge of a scientific revolution, one that could reshape our understanding of the universe and our place within it. The future of cosmology is wide open, and with each new discovery, we come one step closer to uncovering the ultimate truth about the cosmos. As Michio Kaku has so aptly put it, We may be at the beginning of a new era in physics, where the universe reveals its deepest secrets, and a new chapter in the story of the cosmos begins.